Hi everyone, and welcome to data mining, or the term I like to use is machine learning. My name is Ron Zaharsky. I'm the instructor for the class, and this is just a super quick, short video kind of explaining what we'll be doing in class. And I'd like to start off with a demo of what we'll be doing around mid-semester, just so you get an idea of what we'll be up to. So here I have a directory of cat pictures. There's about a little over 1,000 cat pictures. You can see there's different types. Here's just a head of a cat, someone holding a cat, a bunch of cats. There's a variety of cat pictures. And here I have a similar directory of dog pictures. So what I want to do is give my laptop, the program I'm running, these pictures and their labels saying, here's a picture of a dog, here's a picture of another dog, here's a picture of a dog, here's a picture of a cat. So I'm going to tell it what they are. And I'm hoping for that computer programmer, we're going to actually be coding this so the program can learn what's the difference between a cat picture and a dog picture. So that's kind of the goal of what we're attempting to do. So here is that code we're going to be doing. I'm just skimming through it. It's obviously we're not trying to understand it. I'm just trying to give you a quick demo here. And we first load it and unzip the data of all those images of dogs and cats. Let me scroll way down. Keep going. And here's where I'm actually doing the training of that algorithm. And you can see that each training set takes around 9 seconds. We're running on a graphics processing unit, so a graphics card rather than a CPU, and we're using Google Colab. So this is pretty much the format or the environment we'll be using throughout the class. So that's training. I didn't want to bore you with you watching me do 30, 9-second training runs. And then toward the bottom here, I have a couple sample pictures. Let me get there. All right, here. So let me just run these codes again so we see the pictures, or regenerates the picture. So I have that dog picture, and I can ask my algorithm, what do you think? What's the probability that this is a dog? And it says, I'm 99% sure that's a dog picture. We can ask it about another picture. What about that one? So we're going to ask it to predict. And that's, I'm less than, what is that? I'm less than 1/10% sure that that's a dog, so it doesn't sound like it's a dog. Let's look at a final picture here. It's this one where dogs are with other things, but what's the probability that that has dogs in it? I'm 99% sure that has dogs in it. So that's pretty cool. We'll be learning how to do that. A little bit later, we're going to be learning about segmentation of images. That means, given a picture, can you identify the objects in the picture and label them? So here's an example of that, where I gave it a picture of me camping with my dog, and it found my dog and drew a little bounding rectangle around it. So that's where the dog is in the picture. It finds a chair, some bottles, and a cup. It's not 100% perfect. When I gave it another picture of my dogs, it identified one correctly, but the other could either be a dog or a teddy bear. So not 100% right, but close enough. So what happens is we take an image, we convert that image to just an array of numbers, the red, green, blue values, and we give that as input, and the classification will give us probabilities. 82% cat, 15% dog. That's the tasks we'll be working on. We'll be working on other examples as well, other than image classification, but this is just one example. So this is just one part of artificial intelligence. It's the main 99% of artificial intelligence is machine learning, right? So artificial intelligence, computers doing stuff that we consider intelligent. Machine learning, have computers figure out how to do it. And the main part of machine learning nowadays is with deep learning. So those examples I just gave you with segmentation and distinguishing between dogs and cats, that's deep learning. So what will we be doing in the class? We'll be watching screencasts and coding stuff in Python. There's no quizzes, tests, or exams. I'm trying to streamline the course. I mean, the world is chaotic enough right now. I want you to learn the material in kind of a quick fashion so you get kind of good at it, or at least you'll be able to do stuff on your own. So I'm really trying to laser focus on developing skills that we need. So let me go to some websites we'll be using. We'll be working through these videos at Machine Learning Fundamentals, this Inquirium course that I developed. Right now, it's not as populated as I want it to be, but it will be populated soon. So there's some videos to watch. They're basically screencasts a lot of times I explain something and then do a screencast of the nuts and bolts of this is how you program it. So that's what we'll be covering. So watching those videos. In addition, there's this site. It's a GitHub repository. That's the site up there, GitHub Zacharski ML, that gives you all the information for the class. So there's the class syllabus, all the labs we'll be working on, which are these Python notebooks. Let me go to bagging and pasting. It takes a second to render, but it gives information on how to do it. So these Python notebooks, in addition to executable code, also contain a write-up, kind of like a book and an interactive book, let's call it. So that's why we can see pictures here. And then there are some cells that we can actually execute, like that one there and this one up here. So that's what we'll be working in the class. I just wanted to give you kind of I just wanted to give you a quick overview of what we'd be doing. Nothing too elaborate. I hope everyone will be as excited as I am about this course. Take care. We'll see you in the next video. Bye.